you. So my name is Antonio Mirabile. I'm a paper conservator, preventive conservation consultant, and I am a partner of the project AURORA. So as you can see, the long name I never remember by heart, sorry, I have to read it. It's Artwork Unique Recognition and Tracking through Chemical Encoded Data, Miniaturized Devices, and Blockchain Alliance. So you know everything. I think I can go away because everything is in there. Now anyway, we will talk about this project. It's a project which is funded by the European Union. It's in the Europe Horizon project. As you can see, we have 9 partners, 7 nations. It's a 3-year project. We started the 1st of January of this year, and we will finish at the end of 2025. So what are the main objectives of this project? Are to develop a non-destructive anti-counterfeiting marker, so which means a chemical marker. We will mark directly some artworks, and we will use some spectroscopy analysis, which is XRF, which is fluorescence of X-ray. Then we will provide a miniaturized tracking system for to detect all the movement of the artwork. Then deliver a robust and simple artwork authenticity verification digital tool, blockchain. This is something where I'm completely incompetent, so you will see when I will present this part, I don't know almost nothing. So, and then we will, this is where myself, the Hungarian National Museum, and the Balkan Museum Network will have a lot of work to do, is to validate the AURORA protection, identification, and traceability system, which means that we will try to work in close collaboration with museum, with collection, and see does this tracking system can be used on the artwork, or it has to stay for somewhere far from it, because it causes vibrations. Is the chemical marker, for example, compatible with the material of the cultural object? So this is the part which would be the most important. Actually, as a paper conservator, my commitment is with cultural heritage. I protect the integrity of the object. And then we will increase awareness. Actually, this is probably 25 times I presented this project. But in this case, I can present some progression about the project. So the first thing we did, we identified through Interpol database some material on which we would like to work. So wood, canvas, metal, paper, well, you can see they're listed there. But then we also verified the compatibility with the tools we are developing. For example, you can see with fluorescence of X-ray, XRF, when we work with, for example, paper, the response is low, medium. What does it mean? It means that not all the technology will be adaptable to the material. So in some cases, we will have probably the 4 tools, and in other cases, we will have only 1 or maybe 2. So XRF technique is largely used, it's very well known by conservation scientists because it is used to identify, characterize pigments, mostly inorganic pigment, where we have some metal. So you can see, for example, in this case, we have a copy. We can identify on a 1 millimeter what is the distribution of the pigment of the metals. And then this is a unique information because even if we make a copy with exactly the same brush stroke, with exactly the same, how can I say, pigment, we will never have the same distribution of the metals. So this will give a unique identification of the artwork. And then we will make, of course, a mapping of it. In this case, I'm just using a macro photo because just to give you an idea on how the XRF can work, for example, to identify lead or copper on a painting. So, of course, even if we use exactly the same media, exactly the same place, we will not have the same response. So, in this case, XRF, if we make a state of the art, we have done some tests. We have defined the best analysis condition, and we are working with Avale, which is the coordinator of the project, providing the blockchain system that will try to create a platform that will reduce the size of the files, because the XRF is very heavy, and we have to have this kind of information very quickly. The second part is a more interesting part for me, because it's with the invisible ink. We would like to mark artwork with some ink that are visible only with, let's say, infrared or ultraviolet. And of course, we have some in the, already available, already commercialized, but we have problem of chemical stability and migration. So we did some tests. The first one is on marble, and you can see after 25 days, there are these blurring lines, so it's not working really. On wood, for example, after 10 days, it disappeared. On paper, it's a little bit more stable, but again, 5 months later, it's not existing anymore. So we decided to work with zinc oxide. Zinc oxide is, as titanium oxide, probably the most well-known white pigment on Earth. So it is white, but when it is at a nanoscale, it becomes transparent, because you know that nanomaterial, when we reduce the size, all the chemical and physical property, they change completely. So in this case, we can have a metal, which is a very stable pigment, which is transparent, and we can embed the fluorescence and make our chemical marker. So here are just some examples, just to show how stable it can be, and it can be because when we reduce the scale, the size of a molecule, we can also, we say, functionalize. We can make hydrophilic, hydrophobic, so it can be adapted to the different substrates. And here you can see, zinc oxide nanoparticles, how with UV lighting, it is extremely clear, the fluorescence, and it is really stable. Of course, we are at the beginning of the project. We will have to develop more, especially how we will apply this ink on the artwork. And we will have, of course, different scenario. We can have preparation layer. We can have, the preparation layer on the artwork. We can print directly on the artwork, like for paper, for example. The Library of Congress gives us an advice to all the owner of books to stamp, and to stamp in a place where it is visible. So the stamping of something is already in the habit of people working with paper. So you can see we have the different possibilities, and also in some case, to make it more stable, maybe for artworks that are outside, with a protection layer. And of course, all these should be invisible. And then we have also different possibilities. Well, you can see that in chemical markers, we will work with zinc oxide, but we also have silver nanowires, we also have phosphorus, we also have carbon quantum dots. So there are so many things that can be used. We will concentrate more on zinc oxide because we know it's a pigment extremely stable, even if it's transparent. And we can also use the possibility of printing as a form of QR code, so it can have also a number. It can be transferred, for example, with temporary substrate. It can be stamping directly, like we do already with banknotes, which is already existing. For example, if you take $1 with a magnet, it will be attracted because there is some metal in the ink. It can be writing, can be sprayed, can be a stencil, can be dry transfer label. And also we are working on the readout methods. So which means infrared, ultraviolet, lamp, detectors, mobile phone, app. So we are developing all this. For the moment, we are just doing research to see what is existing and what we can bring to make it more accessible to everybody. The second, well, let's say tool is the embedded wireless tracking. So this is very funny because when I was thinking about something wireless tracking, I thought it was like something extremely small. But when we spoke with the engineer, it seems that the smallest wireless provided with the battery today is the size of a shoes box. So imagine a painting carrying a shoes box for the tracking. So we started to work and try to find what will be the best, and at the end we arrive at a size a little bit smaller than a postcard, but thick. more than 1 centimeter, because we need a battery. Otherwise, if there is no battery, the tracker cannot send a signal. The only new thing is that the battery can be charged with a Wi-Fi system. So we don't have to dismount, open, and change the battery. So you see the concept of the embedded wireless tracking. Of course, we will use different things, like the Wi-Fi, the near-field communication, or the LoRa one. And they are completely different because one can give an information up to 4 centimeters, and the LoRa one up to 100 meters. So we will try to find what will be the perfect scenario for this. So you can see we have the tag, which is the tracker, and you can see the anchor and the antenna that will transfer the information to a more centralized system. So here is the tool. It's full of technology, as you can see. And here is this is the final object that we can get, which is 85 millimeters on 54 and 15 millimeters thick, which is, for me, as a paper conservatory, is too big, it's too thick. I mean, of course, it's not, but it seems that it represents an advance extremely interesting in the world of Wi-Fi and trackers. So we trust, of course, our partners. And again, you know, when we work for a European project, we start with what we call a TRL, Technology Readiness Level, which means that there are 9 steps. 1, the research is in the head of the researcher. 9 is already ready for commercialization. From my experience, it's a year for each stage. So in 3 years, if we start from 6, we may reach 9, but if we start with 2, we may reach 5. So we will arrive to the proof of concept, for example. But this is how research works, you know? So this is actually Alessio Ray was talking about European project. You know, the budget of research and innovation for the horizon is 99 billion euro for 2021, 2027. So there is a lot of money. Well, most is for medicine, for energy, nuclear. But even if we get 1% for cultural heritage, it's still a lot of money for projects in 6 years. So, and also when you mount a project, you have to create a consortium, which means that you have to create a net of people. You have to cooperate with other institutions. You have to create a net with different institutions and nations. So this is a good idea for exchanging, I would say, information. So here are just the demo system and development. For the moment, we just are working within 30 to 50 centimeters, but of course, we will go far and far. I think we will do a demo here in the Hungarian National Museum next year, maybe, if I'm not saying something too early. And then we arrive, we have seen we are working with 3 things that have nothing in common. I would say chemical marker, it's a chemist, it's lab work. XRF, it's a tool already existing that can be portable today, so it can be miniaturized. We have tracker, which is completely another field of expertise. So we have 3 professionals working together, and all this information will go into the blockchain. This is the only, I would say, common area that will gather all this information collected during the, let's say, when we will be able to mark or to mark the artworks. So why blockchain? Because it's programmable, because it's secure. Well, this is what they say, actually. Because if we go and ask for security, as blockchain contains also the Bitcoin and the NFT imaging, there is a lot of money inside, so there are a lot of people trying to break this security. So we have people actively working on how can I go inside the blockchain and take this how can I say, tangible money and economy. So it's verifiable, and it is decentralized. This is the most important thing. We will use only public blockchain, which doesn't mean that they are public, the access is to everybody. Is that they are not domain, they're not private. We don't have to pay for the use of this platform. So this is the most interesting thing. And The purpose of AURORA is the preservation, of course, to preserve the main, what? Information, because they don't preserve the object. They're only keeping information about the XRF, about the marking. Also, for example, we have a system where we can geolocalize the place where we did the XRF. Because if you have a bronze sculpture, for example, well, you have to be sure that these few millimeters, when you go to read it back, you go exactly in the same place. So it's easy and fast authenticity verification. This is universally recognized. Blockchain keep the integrity of the information. The information cannot be modified. So it doesn't say that they will authentify the artworks. It says only that they will, the information arrives with certain integrity and will be the same, unless, of course, the owner, they agree to change it. And then there is this traceability, so we can also add in this blockchain all the history of the artwork, so for loaning or for other moment of its life. And it's lending of exchange, it simplifies the exchange between other platforms, so they can be migrated from one to another one. So what does AURORA do? It's in the field of blockchain, it's XRF scanning, so digital identity, chemical marker, and compress the XRF representation. This is the most important thing because this information can be extremely heavy and they have to be found. Another thing that is interesting with this XRF, which I thought it was not possible, is that you can identify, let's say, two objects that are identical. For example, two photos or two ceramics coming from the same production. And if you go and read the XRF at the same point, you will find some differences. So this is extremely interesting for us. And work in progress now, always in the blockchain, because we have seen the other one, is mostly the XRF matching algorithm development just for the reducing the size of XRF. Well, I think I've finished. This is what I could say today about AURORA project, but we will know probably more in a year or a year and a half. Thank you very much.